Sound and Noise, Class 8. Before this, we have studied sound is a form of energy which gives us sensation of hearing. That means we are able to hear because of a property, that is sound. Sound is a form of energy. Now whenever there is drilling or cutting, a machine is used which produces sound. This sound is caused by a property that is called vibrations. Sound is caused by vibrations. Now vibration is where an object moves to and fro, that is, this is suppose a scale, a ruler, and it is kept on some stand, fixed stand, and it is made to vibrate in this direction like this way. So this is a vibration. So when a sound is produced, it is produced by vibrations. Sound is produced by vibrations. Then we have, there are various instruments which produce sound. For example, veena, rudra, tanpura, mridang, dhol, khol. These are examples of stretched membranes producing sound. These are also called as percussion instruments. Instruments like flute, mouth organ, clarinet, etc. The air column vibrates. So these instruments are called as wind instruments. They are called as wind instruments. Air column vibrates in these instruments, so they are called as wind instruments. In the sound producing objects or instruments, we can see vibrations. We can feel the effect of vibrations by sensory experiences, for example, touching and hearing. Now, what is vibrational motion? All type of musical instruments, they produce vibration. When a string of guitar is plucked, it starts vibrating. And if you touch the string of guitar, you will feel the vibration. So any instrument which is producing sound, if you touch it, it will produce vibrations. Sound is produced by vibrations. So what is difference between, now you see, vibrations, if you take a tuning fork, this is a tuning fork. And in this tuning fork, there you see a number is written here, say 512. Tuning fork is a U-shaped metallic object, generally made of steel. Now, when it is striked on a rubber, this is a rubber pad. Here it is a rubber. So when it is struck on this rubber, this end is struck, hammered on this part. So this end is hammered on this part. So this instrument, that is tuning fork, starts producing sound. It starts producing sound. And this sound is of this frequency, 512 Hertz. This is a measurement, 512 Hertz. That means in 1 second, this tuning fork is vibrating in 512 times. This means this tuning fork is vibrating in 1 second, it is vibrating 512 times. Now, you see, whenever there are vibrations, the vibrations they are done like this way. The way they produce waves, vibrations produce waves, and these waves are of this form. Now you start from this point O, one wave goes above, then it goes below, and then comes at this point. Now the distance between point O and A, this distance is called as wavelength. This distance is called as wavelength. Wavelength. So whenever an object vibrates or oscillates, so they produce waves. Sound waves are produced, suppose. So these waves are there, and this distance from starting from O and A, this distance total is called as wavelength. The distance, maximum displacement of the wave or the oscillating particle from the mean position, this is called as mean position, and this is extreme position. The maximum displacement of the particle from the mean position is called as amplitude. This is called as amplitude. This is called as amplitude. Maximum displacement of a particle about its mean position is called as amplitude. Okay. This is an amplitude. So amplitude means maximum displacement. This is the initial position of the wave, and now when the wave is produced, it goes above, then below, then above, then below, like this way. Such a wave is called as transverse wave. This wave is called as transverse wave. Transverse wave. So this distance, initial position, and this here, this distance, one above, one below, this distance is called as wavelength. This maximum displacement is called as amplitude. Then we have time period. Time period. Time period means time taken by wave to complete one oscillation. This is called as one oscillation. One above and one below. So time taken to complete one oscillation is called as time period. It is represented by T. Time period is represented by T. And T is equal to 1 upon N. Time period is equal to 1 upon N, where N is called as frequency. Frequency means number of vibrations made by wave in 1 second. Frequency means number of vibrations made by wave in 1 second. So the relation between time period and frequency is this. Time period is equal to 1 upon N, where N is the frequency. So we have learnt about number 1, wavelength. The distance moved by the wave in one complete vibration or one complete oscillation from the mean position is called as wavelength. The number of vibrations made by a wave in 1 second is called frequency. Time period is the time taken by vibration to make one oscillation. The maximum displacement of wave about its mean position is called as amplitude. Now when you throw a piece of stone in a pond where the water is still, you see waves are formed. These are oscillations. They start from the place where the disturbance is created and they move towards the end of the pond, toward the edge of the pond. And these are waves like this way. These are called ripples. So the same kind of here, it's transverse wave. The waves also move in the same way. That is the maximum displacement of the particle about its mean position, that is from the initial flow to the maximum curve above and below. This is called as amplitude. This is called as amplitude. These points actually they are called as crust, and this is called as trough. The distance between, or the wavelength is also defined as the distance between two crusts, two maximum points. From this to this is also called as wavelength. Okay, this is also wavelength represented by this symbol. This is called as lambda. This is called as lambda. So this is time period. Time period is equal to 1 upon frequency. Frequency means number of vibrations made by wave in 1 second. So what we have learned? Number 1, wavelength. Number 2, amplitude. Number 3, frequency. Number 4, time period. And then we have learned the relation between time period and the frequency. Okay, that's all.